relative changes of in differential calculus, related rates. If we are pumping air into a balloon, both the volume and the radius of the balloon are increasing, and their rate of increases are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure is to find an equation that relates the two quantities and then use the chain rule to differentiate both sides with respect to time. Let's have an example that relates to this explanation. Air is being pumped into spherical balloon so that its volume increases at a rate of 100 centimeter cube per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeter? There are some terms which you need to put in place. Solution. He said, increase rate. It has been given. Increase rate is equal to 100 centimeter cube per seconds. We were given diameter. Diameter is 50 centimeter, meaning that radius will be 25 centimeter. So there's some information given. He said, from the information given, he said the rate of increase of the volume of air is 100 centimeter cube per second. That is the increase rate. So for you to get it clear, that's why I write it again. This is the given, but there is one ungiven which is not given to us, which we are to find. It is the rate of increase of the radius when diameter is 50 centimeter. So the rate of increase of radius when diameter is 50 centimeter. So let's represent all this in a mathematical form. So in representing this in mathematical form, we said mathematically this this can be represented by let V be the volume of the balloon, and R be its radius. So now, meaning that the V dt is equal to 100 centimeter cube per seconds. The R dt is not given, we don't know it, when R is equal to 25 centimeter. From the value given, the diameter is 50 centimeter, therefore the radius is 25 centimeter. So when the radius is 25 centimeter, in order to connect the V and the R, so we first relate V and R by formulating a formula. So in this case, remember, the volume of a sphere, you're able to know the volume of sphere V is 4/3 pi r cube. Why? Because balloon has the shape of sphere. So the volume of a sphere is 4/3 pi r cube. You know, I've said it earlier that in order to connect the V dt and the R dt, we need to relate V and R by formulating a formula. How do we formulate a formula? So let's try to formulate a formula and see how it works. So by formulating a formula, we can say that the V dt is equal to the V dr dot dr dt, meaning that the V dr dot dr dt. How could we now get the V dr? Since we are able to know that the volume of a sphere is 4/3 pi r cube, so meaning that the V dr will be 3.4/3 pi r square. So meaning that the V dr is equal to, this we cancel this, it will give you 4 pi r square. That is the V dr, and we are able to now want to relate the two together before we substitute. So in relating the two together, we know that therefore the V dt will now be, instead of writing the V dr, we will now write 4 pi r square dot dr dt. That is the rate in the radius. So this thing connotes a chain rule. We use the chain rule to formulate a formula. So meaning that the V dt is equal to 4 pi r squared dot dr dt. So now, so if we put r, if our r is 25 centimeter and our dv dt, it is 100 centimeter cube, that is centimeter cube per seconds. So in this equation, and you know that from what you have able to be given, let's make the r dt as the subject of the formula. How do you do it? Remember that our dv dt is equal to 4 pi r square dot dr dt. So let's divide both sides by 4 pi r square. So in dividing the both side by 4 pi r square, mean that the r, the t will now give us 1 over 4 pi r square dot the v dt. That is just the meaning that the v dt is 100 centimeter cube per second. So therefore, in getting the value for the r dt, you will just substitute the value now. So in substituting the value, getting our answer to be the r dt will now be 1 over 4 pi onto 25 squared times 100. So in multiplying all this, 4 will cancel this, remain this. In mathematical settings, it will give you, there's a pi. 4, this is 25, we divide 100, it will give us 4. 4 divided, so it will give us 1 over 25 pi. So meaning that the t is 1 over 25. So in overall, you now say the radius of the balloon is increasing at rate of 1 over 25 pi, which is approximately to 0.0127 centimeter per second, when the diameter is 50 centimeter. That is all. So it means the radius of the balloon is increasing at rate of 0.0127 centimeter per second when the diameter is 50%. Example 2. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 4 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? If you're able to see the diagram, you see the wall and the ground. The length of the ladder is 10 feet. And the wall of the ladder represents y-axis and the ground represents x-axis. Let's also see the diagram when it said, how fast is the top of the ladder sliding down? As it's sliding down, this ladder will be coming down and the x will be increasing. That's all the format. Let's see the diagram, and you see now that the y dt is going down. That is the y-axis. The x-axis is increasing as far as the ladder is slowing down. So now let's prove this mathematically to give a better explanation. So now, there's some given values. Let's write it out. We were given change in x with time to be 4 feet per second. But we were not given this is what we want to find. We were not given we have to find this at x is equal to 6 feet. Where I deduce all this, let me bring it out. You're able to see that from the question, it said a ladder 10 feet long rests against a vertical wall. If the bottoms of the ladder slide away from the wall at a rate of, that is the x dt is 4 feet per second. How fast is the top of the ladder sliding down. That is the y, the t, which is unknown. When the bottoms of the ladder is 6 feet from the wall, 6 feet from here, that is x is equal to 6 feet. So that is how we solve a wall problem. So now, by Pythagorean, Pythagorean's theorems, you know that hypotenuse squared, that is 10 squared, is equal to x squared plus y squared. So which is 10 squared is equal to x squared plus y squared. So therefore, x squared plus y squared is equal to 100. So now, let's differentiate with respect to t. Differentiate with respect to t by using implicit differentiation. Implicit differentiation. So in differentiating this, it will give us 2x. I'm coming. It will give us 2x. Sorry. It will give us 2x dx dt plus 2y dy dt is equal to 0 because 100 is a constant. So now, let's try and make dy dt as a subject of the formula. So we have from that area, let's make, you said 2y dy dt is equal to minus 2x dx dt. So let's divide both sides by 2y. Let's divide both sides by 2y. So we have 2y dy dt is equal to minus 2x over 2y dx dt. So mean that the y dt is equal to minus 2x over minus 2y, sorry, plus 2y dx dt, which will give us minus x over y dx dt. Now we will be given the value of x. Now, in given the value of x, we try to deduce one Pythagoras formula here. Let's use it in that angle. That we have x squared plus y squared is equal to 100. Now, we'll be given, when it is 6 feet, it means 6 squared or y squared is equal to 100. So 36 plus y squared is equal to 100. So y squared is equal to 100 minus 36. So y squared is equal to 64. So the value of our y will give you the square root of 64, which is equal to 8 feet. Now, if y is equal to 8, and the formula says that the y dt is equal to minus x over y dx dt. We all know the value of the x dt from the question given to us, which shows that the x dt is 4 feet per second, the rate at which the ladder is moving at the ground side. So, which will be equal to So what is the value of our x? Minus 6 over 8 dot 4. So here 1, here 2, 1. So making 3. So therefore the y dt is equal to minus 3 feet per seconds. So we have minus 3 feet per second. So let's interpret this value in written form. So the fact remains that the y dt is negative means that the distance from the top of the ladder to the ground is decreasing. At the rates of 3 feet per second, the top of ladder is sliding down. Sliding down the wall at a rate of 3 feet per second. So the written of this conclusion is this conclusion is our answer, because it is minus because the ladder is sliding down. In another form, that is the top of the ladder is sliding down the wall at a rate of 3 feet per second. 3. A water tank has the shape of an inverted circular cone with the base radius 2 meters and height 4 meters. If water is being pumped into tank at a rate of 10 meters cube per minute, find the rate at which the water level is rising when the water is 3 meters deep. So when the water is 3 meters deep, so now this is the diagram of the inverted circular cone. So the big radius is 2 and the smaller radius is h. The height of smaller cone of the height of the water is h, which we don't know, and the height of the big height of the big cone is 4. So now he said the quantity of h, the quantity of v and h are related by a question. Let's say the quantities v and h are related by the equation, by an equation. So v is equal to 1 over 3 pi r square h. So this is the volume of the cone, and this is the equation that relates the v and the h together. Now by similar triangle, the small radius over the big radius will be equal to the small height over the big height by applying By applying similar triangle, we have R over 2 is equal to H over 2. We have 2R is equal to H over 4. H over 4 so we have 4R is equal to 2H. So what we want to make we want to relate everything in one value, so we can have V and H. So we have R is equal to 2H over 4. So the value of our R will now be H over 2. So let's put this value. So volume will now be 1 over 3 pi. Instead of writing R, it will be R H over 2 square dot H. So our V will now be 1 over 3 pi H cube over 4, which is pi H cube over 12. So now, if the volume is pi H cube over 12, so V is now pi H cube over 12. So let's try to use an implicit differentiation to find the V dt. In finding the V dt, we have 3 dot pi over 12 dot H square, because the 3 must have come here. So dot dH dt. So this cancels 12. So we have the V dt. So this is 4. We have pi H squared over 4 dH dt. So let's try to make the H dt as a subject of the formula. So in making the H dt, because we have the V dt is equal to pi A squared over 4 dH dt. Multiply the both sides by 4 over pi R squared. So the H dt will give us 4 over pi H squared dV dt. Only that we divide both sides by pi A squared over 4. So to now reciprocate to give us this. And you know that from our question that this we have to find the rate of change when the height is 3 meters and the V dt is 2 meters cubed per minute. So the rate of change of the height at 3 meters will now be 4 over pi, the height of the meters at what we want to calculate, dots. Now the V dt, that is the rate of change of the volume, which is 2. So now it will give us 8 over 9 pi. So meter per minute, because we want to find the rate of change of the height per unit time. So therefore, the water level is rising at rates of 8 over 9 pi, which is equal to 0.28 meter per minute. So this is the answer for this. So from the question, so the rate at which the water level is rising when the water is 3 meters deep. So this is how it is. If you firstly find the equation that relates the volume, the V and H, which is the volume of the cone, and we try to make the similar triangle. Later we try to find what exactly we try to put the value to make it V and H only, so you can differentiate the V dt in an implicit form. Implicit differentiation, so to now get the V dt. So we now make the H dt as a subject of the formula and we substitute. So to have the water level is rising at the rate of 8/9 pi, which is 0.28 meter per minute. Example 4. Car A is traveling west at 50 miles per hour and car B is traveling north at 60 meters per hour. Both are headed for the intersections of two roads. At what rate are the cars approaching each other when car A is 0.3 mile and car B is 0.4 mile from the intersection? Therefore, so this is car A moving to here at x axis and car B moving to the north at y axis. And the distance between them, between the A and B, is Z. So the first thing we have to consider is by Pythagorean. Theorem. We have z squared is equal to x squared plus y squared, because the Pythagorean theorem says the hypotenuse squared is equal to the sum of the opposite squared plus adjacent squared. So since we have been able to have this, let's differentiate each side with respect to t. So in differentiating this with respect to t, we have 2z, the z, the t, because we are using implicit differentiation. We have 2x, the x, the t, plus 2y, the y, the t. So let's try to divide all through by 2. Divide all through by 2. So we have z, the z, the t is equal to x, the x, the t, plus y, the y, the t. So let's now make the z, the t, as a subject of the formula. So we now have the z, the t is equal to 1 over z onto x, the x, the t, plus y, the y, the t. So now when x is equal to 0.3 mile and y is equal to 0.4 mile. So by Pythagoras, as we said earlier, that z squared is equal to y squared plus x squared. So our z squared will be 0.3 squared plus 0.4 squared. So z will be the square root of 0.3 squared plus 0.4 squared, which will give us 0.5 miles. So let's now substitute the value of z, x, and y to this formula to now get the rate from the question. The question says at what rate are the car approaching each other when the car is 0.3? Because you have to calculate the distance between them. So before you're able to get, it is what the distance between them you're able to use to find the rate at which the car approaching each other. So therefore, let's substitute the value. So to now have the z dt is equal to 1 over 0.5 onto 0.3 on minus 50 plus 0.4 on minus 60. So let me explain how do we get the minus 50 and so the reason I'm putting minus 50 and minus 60 is because the car A traveling west at 50 miles, both are headed for the intersection. So they must apply brake, they must not speed. They must not speed, so that is why they are decelerating. So their movement is decelerating, not accelerating. So in the speed, their speed are reducing. They are decelerating their speed. So that is why we now have minus 50 and a minus 60. So by the time you apply your calculator to press, we have minus 78 mile per hour. So the cars approaching each others at a rate of 78 miles per hour. So that is the rate at which they approach each other. A man walks along a straight path, and this is number 5, at a speed of 4 feet per second. A spotlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the spotlight rotating when the man is 15 feet from the point on the path closer to the light? This is the man. Is the moment it starts here, the beam, you see that the beam is focusing on the man and the angle is moving, but the angle is the same, but it's moving. So now the question says that, said, at what rate is the spotlight rotating when the man is 15 feet from the point? So we said the fact given from this question is the rate of change of the distance is given already to be 4 feet per second. So we have to find the theta, the t, when s is equal to 15. So when s is equal to 15, and this is a right angle the man follows. So meaning that tan theta is opposite over adjacent. So therefore, you said tan theta is equal to opposite over adjacent. So making x to be 20 tan theta. So by differentiating with implicit differentiations, we have dx dt is equal to 20. By the time you differentiate, tan theta will give you sec square theta d theta dt, because we apply implicit differentiation. So let's try to make the theta dt as a subject of the formula by dividing both sides by 20 sec square theta. So the theta dt give us 1 over 20 sec square theta dx dt. So this is the value of the theta dt. But to recall that sec theta means 1 over cos theta. So if we have sec square theta, we mean 1 over cos square theta. So sec square theta will be 1 over cos square theta. Therefore, 1 over sec square theta will be cos square theta. So that is just the meaning. So now, instead of now writing 1 over 20 sec square theta, it will just give you that the theta, it will just give you that the theta dt is equal to 1 over 20 cos square theta dx dt. So that is, and from here we have been given the x dt to be 1 over 20 cos square theta dot the x dt is 4. So therefore the theta dt is now 1 over 5 cos square theta, because 4 will cancel 20 to give us 5. So now the question is now that when s is 15, let's find the length of the beam. You know, from the question here, we're given the x. They now say that when this s is now 15 feet, if this s is now 15 feet, meaning that this is 15, so let's find here by Pythagoras. Let's call here z. So let's find by Pythagoras to say that z squared is equal to 20 squared plus 15 squared. So our z will be the square root of 20 squared plus 15 squared. So z will be 25. So the value of z will be 25, due to the diagram. So therefore, we now need to find, so if our z is 25, so let's find the cos theta here. Cos theta is adjacent over hypotenuse. So mean that cos theta is equal to 20 over 25. That is where I'm going to. So that is the only thing I need, meaning that cos theta is equal to 4 over 5. That's all. So if my cos theta is equal to 4 over 5, so let's apply what cos theta is here. If our the theta dt is equal to 1 over 5 cos square theta, so now therefore we have the theta dt is now equal to 1 over 5 cos square theta. This is just the meaning. So therefore we have 1 over 5 times 16 over 25, which is equal to 16 over 125, which is equal to 0.128. So mean that the theta over the t is equal to 0.128. So in representing this, we said the spotlight is rotating at a rate of 0.128 radians per second. So that's just the answer. So please try. Thanks for watching this video. And if you see that what we are doing since morning, since we have started, Ask Mini, share this video and also subscribe. Thanks.